All right, welcome to section 4, which is about concentration and dilution. So concentration is something that you might be familiar with. When you say something is concentrated, what you're really doing is you're talking about the measure of the amount of solute dissolved in a certain amount of either solvent or solution, depending on what measure of concentration you're looking at. Pictorially, you could probably tell if something is concentrated just simply based on color. Like if you were to look at these two flasks, you could probably guess that the one on the left is more concentrated. But what you're really saying is that there are more solute particles per volume of solvent or solution, whereas the one on the right is more diluted, meaning there are less solute particles there. So there's lots of units of concentration, but the one that we're going to be talking about in Chem 151, particularly in this section, is molarity. Now we've seen molarity before. We saw it in topic 2 as a brief introduction, and then we also saw it in topic 9. We're going to do a little bit more practice with it right here in topic 10. So to review or to recall, what is molarity? Molarity is measuring how many moles of solute you have per liter of solution. Okay, and remember, solution is solute and solvent together. So another way to talk about molarity is molar concentration. So for example, we would say 1.5 molar, right? And so this 1.5 molar, as an example, is the same thing as saying for every 1 liter of solution, you will have 1.5 moles of glucose, or whatever it is that you're looking at. Okay, so the 1.5 capital M can just simply be converted to 1.5 moles for every 1 liter of solution. And so that's what molarity is. So before we do practice with molarity later on, let's look at the equation, moles over liters, and let's look at some example problems of how we can use that to solve for some unknowns. So example 7 in our notes asks us to find the molarity of a solution by adding 5 grams of NaCl to a 100 milliliter volumetric flask and filling it with water to the standardized line. So essentially we are taking this 5 grams of table salt, we're adding water to ultimately make a solution. Okay, and as a result of that, I want to know what's the molarity. So I can calculate molarity by taking moles of solute, divide it by the total liters of the solution. So molarity is equal to moles over liters. Well, I don't know how many moles of the solute I have. The problem doesn't tell me that, but it does tell me how many grams I have. So I could figure out how many moles there are by simply doing a molar conversion. And so I'm going to actually do that up here. So this is review. This is from topic 2. But if I have 5 grams of NaCl and I wanted to convert that into moles, I would take the molar mass. And specifically, I would set it up just like this. So 1 mole of NaCl has how many grams? So the molar mass for NaCl, just for time's sake, I'm going to write that down. It's 58.44. That's the molar mass for NaCl. So if I take 5.00 and divide that by 58.44, that's going to give me the number of moles that I have. And so that's going to be 0.08556 moles. I'm going to go out of an extra sig fig. And so that's how many moles is equal to 5 grams of NaCl. So that's what that would go up here. And so I'm going to write that down, 0.08556 moles. Now the second part is I need to know, okay, that's the number of moles for what volume, okay? The problem tells me that I'm using a 100 milliliter volumetric flask. So what that means is once I fill it up with water, what's going to be the total volume of the solution? It's going to be 100 milliliters. But I don't want to write 100 milliliters. I need to convert that into liters. However you do that is up to you, but essentially you should get, that's the same thing as 0.1000. Notice how I keep all those sig figs, liters. So now I have how many moles there are divided by how many liters of solution it would end up occupying. And so all I have left to do is just simply to calculate. I just have to divide that. So that would end up being 0.856, and then my unit is capital M. Okay, so that would be the molarity of that particular solution. Let's look at another example. So I keep the same equation up here so we can have that as a reference. Now we're looking at example 8. It says find the mass of solute made in 50 milliliters of a 2.50 molar solution of sulfuric acid. So this time I'm actually given the molarity and I'm given the volume. I'm asked to figure out then what would the mass be. So if molarity is moles over liters, I'm going to rearrange this, okay? And so I would multiply both sides by liters, okay? So that would cancel out there. So I would end up getting a different rewritten equation of my moles would just be my molarity times my volume, okay, in liters. Now, ultimately, we're going to have to figure out mass, but if we can figure out how many moles, we can then go the next step to figure out what the mass is, right? So my number of moles can be found by taking my molarity, which the problem gives me. It's 2.50. Now, I'm not going to write molarity. I'm going to write moles over liters. It's the same thing, but I'm doing that for a reason, because I want you to see that when I multiply it by the volume in liters, which milliliters, if I convert this to liters, it would end up being 0.0500 liters, right? When I multiply those two, the liters cancel out. That's why I wrote it like that. And so 2.50 times 0.0500, I end up getting my number of moles would be 0.125 moles. And then the final step is, I don't want to know how many moles, I want to know how many grams. So this is where I do a molar conversion. 1 mole of H2SO4 would have a mass of, and I actually don't know what that is, so let me calculate that real quick. I'm doing the molar mass of H2SO4. So that's going to be roughly 98.09 grams. So 98.09 grams. The moles will cancel out when I multiply. So 98.09 times 0.125, that's going to give me, with 3 sig figs, 12.3 grams of H2SO4. So that would be the mass of solute that I would need. Let's do one more practice problem. So this time I have the molarity and I have the mass of the solute. I just need to figure out what's the volume. Okay, so starting out, I'm going to write out my equation. My molarity is equal to moles over liters. This time I'm asked to solve for volume, so I'm going to want to rewrite this equation. Okay, and so this can be rewritten as liters is equal to moles divided by molarity. Okay, that's just using algebra. That's rewriting the equation, so hopefully everyone is okay with that. So I can solve for my volume by taking the number of moles divided by my molarity. Well, I know what my molarity is on the bottom. It's 3.90. So 3.90. And once again, I'm going to write moles over liters rather than capital M, just so you can see how units cancel. But on the top, I can't put 8.50 grams because otherwise the grams won't cancel with anything. I have to convert this into moles. Okay, so I'm going to do that. Hopefully you're feeling comfortable with that so far. We have 8.50 grams of potassium hydroxide. I need to convert that from grams to moles. So 1 mole of potassium hydroxide. Let's figure out what that would be. Okay, so roughly that molar mass is going to be about 56.11 grams. And so when I divide 8.50 by that mass, okay, I'm going to end up getting my number of moles is approximately 0.1515 moles. So that's what's going to end up going on the top here, 0.1515 moles. And now you can see how the moles will cancel. And so your volume is going to end up being in liters. So if I take 0.1515 divided by my molarity of 3.90, that's going to get me 0.0, and let's say I need 3 sig figs, so 0.0388. Now that unit is going to be liters. Now technically you could leave it like this because the problem's not specifying what unit it should be in, but it'd probably be better to convert this, since you saw the other examples, we usually have it in milliliters. It'd probably be best to convert this into milliliters. So if you leave it like this, that's fine, but it's probably better to convert to milliliters, which would be 38.8 milliliters. So either one's okay. I'm fine. Just make sure that you are having the correct sig figs as well as the correct units. Now, what happens when you want to dilute something? So let's say you're looking at a solution and it's really concentrated. You want to dilute it. What do? Well, the process of diluting is just simply adding water. If you add water, which is the solvent, that's going to make the solute to solution ratio larger, meaning that there's not going to be as many particles per air or per volume of solution. So to figure out what the new concentration would be, we need to use our dilution formula. So you've seen this before probably. M1 times V1 equals M2 times V2. The M's stand for your molarities. The V's stand for volume. And since you have V on both sides, you don't have to, as long as it's the same unit, it doesn't matter. You can keep it in milliliters. You can change it to liters as long as it's the same on both sides. The ones stand for concentrated. So this is the molarity and volume before you add water. Okay, so before water. And then this is the molarity after diluted. So after you've added water. Okay, so you just plug in those values and solve for whatever it is the problem wants to ask for. So taking a look at example 10, it says what volume in milliliters of a 1.20 molar HCl solution must be diluted in order to prepare 1.50 liters of 0.275 molar HCl. The problem itself is actually very simple, but what gets a little complicated is there's a lot of numbers and a lot of, lot going on, right? And so it might be a little confusing. So just real quickly, I'm going to actually draw kind of the situation, what's going on, and then we'll look at the math. So essentially, you have this HCl here. Okay, and this HCl is 1.20 molar, right? That's the concentrated HCl. Essentially, what I want to do is I would like to prepare, 1.50 liters of an HCl solution that has a molarity or concentration of 0.275 molar. So obviously diluted because it's less concentrated than 1.20 over here. So the question is saying, okay, how much of this concentrated should I add in order to get this diluted solution, right? So that's the situation going on. And so what I'm going to do is I'm going to use M1 times V1 equals M2 times V2. Specifically, what's the molarity before I added water? The concentrated. That's the 1.20 molar. And what volume of that is actually what I'm trying to solve for. As a result, the new molarity should be 0.275. That's what I want to make, 0.275 molar. And the volume that I want is going to be 1.50 liters. That's what volume I want. So the setup you can see is actually pretty simple once you understand what's going on. I'm going to divide both sides then by 1.20 molar. So that'll cancel out there. And I'm going to divide by 1.20 molar on this side. The molar units will cancel out, and so my final volume will end up having the unit of liters. So if I do 0.275 times 1.50 and divide it by 1.20, keeping three significant figures, my answer, my volume of the concentrated HCl is going to be 0.344. And since it was liters on this side, it's liters here. Now what I'm going to do is I'm going to actually write that in milliliters, but they're both the same thing. Okay, and so that is the volume of HCl, the concentrated HCl that I would need to take. Now the second question is asking how much water did you add? Well, think about it. Your solution that you ended up making was 1.50 liters, which actually is the same thing as 1,500 milliliters. Well, that 1,500 milliliters, of that 1,500, 344 of it is the acid, right? So the remaining amount must have been the water that you added. So to solve for how much water was added, I'm just going to take 1,500 minus 344, and I end up getting that I must have added 1,156 milliliters of H2O. That was the amount of water that I added. All right, and so that would be an example of a dilution problem. We have just a little bit left of this section, so we'll see you in the next video.